Welcome to GDP's Game Jam 2020. This is a final project for the Game Development Advanced Programming Postgraduate at Fanshawe College. My name is Felipe Bellini, and I'll be going over the technical aspects of Thescent, an OpenGL implementation inspired by the original Thescent of 1995 created by Interplay Entertainment. All the information contained in this video and more can be found in the game's official documentation. The first feature that I'll be describing is the installer that I created for this project. If you go to the solution directory, you should be able to find game setup and game setup.full. The difference between these two projects is that one will generate an MSI package, and this is a bundle of packages, meaning that this will not only install the MSI, the contents of the MSI, but it will also deliver the Visual C++ runtime and OpenAL SDKs, which are required for the game. This was created using Wix toolset. Wix is a programming tool for installers that was created by Microsoft, and it was the first open source project that Microsoft released to the public. If you go over to the installer, you should see this window here. There's another one. Installing the game, then the packages. Okay, alright. We should see a shortcut in the desktop. The first feature we see here in the game is a loading screen. This is only possible because I have multiple threads inside the game, and there's about 5 threads plus the main thread. One's the data persistence thread, that's the thread that's loading files in the background. There's also threads for physics, for the Lua scripting system, for sounds, and artificial intelligence as well. Another thing that I can discuss here in this screen is the graphical user interface. For that, I studied a C API called Ingui that creates nice looking graphical user interfaces. I've integrated this in 2 steps. The first one being the menus here that we were seeing, with some buttons here, showing information to the user. This gives us an idea of a professional game of sorts. And in the second step, what I have created is the HUD of the ship. In the beginning of the project, I started working on FBOs to create the HUD. So I had off-screen textures to have this thing here, the weapons panel and the health counter and the items panel. But then, as I progressed and started doing the GUI stuff, I had this idea of making the HUD using the proper C API, and it was really nice looking the way it is right now. Let's continue to the game and check out other features. Here's our first scene. You can see some transparency here out of the window. Outside, the stars appears to be moving, and this was done because in the beginning I wanted to have a sort of a distortion field, sort of a force field around the space station, and that would cause the stars to look like they are shifting and outside. So there's a couple of ideas to do this by using like a sphere mesh or with a superimposition of textures or something like that in the shader. But the idea that stuck to me was having an invisible object in the middle of the map, and I have the skybox look at this object constant. So the object is doing a circle movement in the middle of the screen, and the skybox observing it, and that's what generates um, this kind of a distortion thing that we see in the sky. Looks really interesting. Here's our first corridor. Here's our first enemy, the turret. Notice how it's turning towards me. That's AI. The turret has the look at AI and also an AI to fire at you. Here's the door, but it doesn't open because it requires an action. We'll see this later. Here's another use of transparency. This one is using this card. And you can see the reactor on the other side. I'll be discussing the reactor later on. The other door. So this thing here, the door that's opening, that's a Lua script. It's a way to do animations. This is only possible because the physics system has a collision callback that returns which entities collided against each other. So I know the game code knows that if the player is colliding with the door, then the action to open the door should be triggered, then the script for the door is called. The same idea is used for the enemies in the game when the projectiles hit the enemies or it hits the player. Same idea. We have the health counter here on the ship's HUD to show that. Another enemy, the drone. Notice how the projectiles, upon collision, take damage, cause damage to the player. Here's an imposter. This is an imposter that has an AI behind it, so it always turns towards the player. This is the first item in the game, and when I collide with this item, the item will show in the HUD of the ship. More transparency here. So now that we have the anti-cloak item, we can press M to toggle it on or off. This effect is happening in the shader is path on top of the texture of the frame buffer. So what's happening here is that the game itself, all the whole scene we're seeing here is being rendered off screen to a frame buffer, and because of that, I'm able to have the crosshair of the ship separated from the controls of the ship and the HUD of the ship. And so when we press N here, then it toggles on or off the path on the frame buffer that covers the texture with a tone of green. And it also kind of looks like a glass. It has some lines in it. Very interesting. So notice how that door is shut. If I press this button here, the door should open. So it's the same idea with where I'm colliding with something and triggering the Lua script in the background. There's another enemy in the game. In this scene, the player is expected to take two actions. One is rescuing the hostage, and the other one is to get the second weapon in the game. The cannon is represented by the Zorb that we're seeing here in the center of the screen. This is using a sphere texture that's being offset along time in the shader. This gives us an illusion that the cannon is made of plasma or dark matter or something. Like the other projectile in the game, that's the laser, the cannon also is capable of emitting light. And this is possible because the engine that I wrote is using the entity component system. So I made the lights components in the game, and these components are attached to each projectile. There's a light that's attached to the projectile, and wherever the projectile goes, the light source accompanies it. So the video system will pick this up and will draw the light to the shader, just like the other lights in the game. So the other thing here is about the hostage. The hostage has a state machine here that is capable of identifying if the player is too far or too close to it. The reason for that was that in the original Thescent game, there is a couple of hostages that keep signaling to the player when the player finds them in the game. And this was a use case that I found for the vertex animation using the shader in this game. The idea that I had was for the character to be constrained in a force field. So because the force field is kind of holding him back, he's only capable of either struggling inside the force field or asking for help. So that's what happens with the distance that I just mentioned. If the ship is too far, then the character will struggle. As you can see, he's trying to bash his way through the force field. And if I get too close to it, it will run towards the ship because it's as if it's noticing that help is arriving. Once you capture the hostage, then the boss is placed into the game. If you go back to the scene where the boss is placed, we can't see the boss, only if we press N for the anti-cloaking device. We can see that the boss is shifting colors. That's an effect in the shader where I take two colors and interpolate over time between these two colors. So in this particular scene, we have a couple of graphic effects. For instance, the walls here, they are single plane mesh that's distorted, that's scaled, and its UVs are then manipulated in the shader, so we can put these quad textures on this distorted rectangle that makes up for this whole wall. It was a good idea for avoiding drawing too many objects on the screen and also showing off tiling, texture tiling. Another use of texture that I'm doing here is in this section. As you can see, this side is different from the other side, and that's because the reactor portion of the scene is using texture blending. So there's two textures here, one for this red circle here effect that we have on the ground, and the other one is the regular steel texture. That happens for both the ceiling and the ground. Another effect we have here is another feature that we have here is in the reactor. The reactor has a number of details. It uses transparency that we have already seen using the alpha. It's using a particle emitter with imposters. For the imposter, I'm using a texture that looks like a ray, and when I'm firing the imposters, it looks like the ray is moving, which is kind of nice. Another feature is that because the particles have a high number of meshes in the game, I used instance rendering for that. So this is a section of the game that uses instance rendering in the shader. What this does basically is that it passes a bunch of matrices, model matrices, to the shader, and then the shader will use GL instance ID. to identify which instance it's supposed to be drawing. And on the CPU side, it only calls one function that's GL draw instance or something. Another feature that I also have here is the use of multiple shader programs. This was the last thing that I worked on for this project. And having multiple shader programs here, it's kind of tricky, but it works all right in this setup. The imposter, and the instance rendering is separate in another fragment shader and instance rendering shader. That's not in the other shader, the Uber shader, which is kind of nice. Because of the time frame, I wasn't able to separate all of the internal shaders of the Uber shader, so I just have these two shader programs acting at the same time. And you can see this when we go to the game here. If we go to our assets, there's a XML file that outlines the shader programs that are in use. So we have these two shader programs. The first one is the Uber shader, and the second one is the shader that the reactor is using, which is instance rendering and imposter shader. So once the game is about to end, the last thing that the player has to do is to shoot at the reactor, destroy the reactor, and flee. And we should be able to see yet another feature in this game. Notice how the reactor exploded, and as the reactor exploded, it blows the door of the space station away so the player can run and go back home. This is an effect. It's a shader effect where I take the vertex of the capsule of the reactor and offset it along time. So the reactor looks like it's growing to a certain size, and it grows for a couple of seconds and then it will vanish like a proper explosion. And now we are about to leave the game. In this portion of the game, we have a ghost object here. It's more of a physics thing. It's basically a cube that's invisible, and when there's a collision against this cube, then we'll see another scripted animation. So there you go. You can see the spaceship fleeing, and the camera is moved back to the space, and the game is over. Also, another thing that I've implemented here is the pause menu. One way to notice this, the skybox will continue with that distortion effect, but if I press pause, then the effect will stop happening. That's because I'm playing with the delta time inside the game. So whenever you press pause in the game, it just makes the delta time 0. So that gives us the illusion that everything is standing still in time. So that was my final project for the GDP, for the game jam. Thanks a lot for watching. Thanks for playing the game. For more information about this program at Fanshawe, please still contact the teaching staff at the college. For this project, you can contact me on this channel or send me an email and we can talk about it. Thanks and goodbye.